and he's the head of the post-harvest laboratory at AV. With that, please help join me in welcoming Mr. Martin.
Thank you, Sam. Good afternoon, ladies and gentlemen. I'm going to present to you the work that we do in post-harvest in the EV-ADB project, and I would like to try to do a little bit also the link to the topic of the conference. So I'm going to briefly cover post-harvest problems. Samo Hanti and Dr. Schäfer-Preuß have already mentioned the losses, the magnitude of losses. I will give you an example how post-harvest also affects health by using one example from our research on mycotoxins, and then point out some solutions and some approaches that we are using in order to trying to scale out these solutions. So the losses, they are in the range as we heard already, between something, we say between 15 and 25% physical losses along the whole post-harvest chain. And they vary very much depending on the situation, like in the Ariyavadi Delta in Myanmar. I just came back from there recently. They had in some villages, they had measured the losses and they went up to 43% because they didn't have mechanized harvesting options and they had no time to do the manual threshing after cutting the crop because they wanted to bring pulses in. So the numbers are very variable, but on average I would say there are somewhere between 15 and 20% in Southeast Asia physical losses. And then on top of that we have quality losses, and they result usually in loss of income in the markets, and that can be depending on the differentiation of market quality standards and so on, between 10 and 30% of additional loss in value. And on the bottom you see with mechanical options for post-harvest, we can bring down these losses significantly. So I guess something like in the range between 5 and 10% is a very realistic number. So how does post-harvest affect basically health and nutrition? So we have the physical losses that I mentioned. If we reduce those, we mainly make more food available. And it was mentioned before, there was a food shortage in 2008. So I think the project initially came about to reduce those losses. But we also have this quality losses, and they do have direct implications for health. And for example, in milling, if you just do the milling improperly, brown rice we all know is more nutritious. If you over-mill the rice, for example, you remove a lot of micronutrients. And there are products from rice milling that are more nutritious than just the white rice. There's the issue of fortification, I will not elaborate on that. And then there is this whole area of quality loss, and the biggest effect we have there is basically contamination of rice with mycotoxins. And there are 3 major groups of fungi that generate mycotoxins: Aspergillus, Fusarium, and Penicillium. And they produce, basically some very toxic substances, which can be I always have problems with that word. They can cause cancer, let's put it that way. and nephrotoxins and neurotoxins as well. And on top of being basically toxins, they are also anti-nutritional factors. So for example, mycotoxins can cause poor growth in children and suppression of immunity in children and young animals. And one of the very acute ones is aflatoxin, and in the past it was said that aflatoxin is not a problem in rice. But in 2006, starting 2006, there were a lot of incidents in the literature where people had taken market samples in Southeast Asia, also in India, and they have actually found quite alarming numbers of aflatoxin in rice. So what we thought is we do a small experiment in our post-harvest projects. We sort of take that on board, and we simulate different conditions that we find in farmers' fields. And the major reasons for the quality losses are, you see it there on the top, it's basically delays after harvesting. So farmers cut the crop and leave it lying in the field like that, or improper drying, delays in drying, and then very important, improper storage. And those are basically the problems that we are trying to address in our project anyway. And these conditions basically provide a very favorable microclimate for this fungi to develop and the mycotoxins to develop too. So we set up an experiment with mainly 3 treatments, which looked at optimum post-harvest as we see it, which is mechanized harvesting, machine drying, basically within 24 hours after harvesting, and then we used hermetic storage. I will come back to that in a moment. And then the second treatment basically just delayed the drying after harvesting by basically leaving the grains in the cut crop in the field and leaving it there for 6 days, like many farmers in the region still practice. And then the third treatment was basically cutting and immediately threshing, but then keeping it at a high moisture content. We only use 16%. In the Philippines, the government still says that 18% is safe for 2 weeks of storage to overcome the shortcomings in dryer capacity. And we only used 16%, and we got quite some significant results. And the fourth one was sort of a combination of the bad practice management. We stored for 6 months, and then we measured basically the typical parameters like physical quality, fungal infestation, aflatoxin contents, and so on. So this shows some of the results. You can see on the left is best practice. We had the blue one is after 3 months, the red one after 6 months of storage. So we have minimal levels of aflatoxin traces, and they are within sort of the sampling error, I would say. And if you do the field drying only and then dry immediately after and thresh and then dry immediately after threshing, then we also have quite small amounts. But if you do temporary storage at 16% for 2 weeks or 17% in the trial, then we get quite significant amounts. But if you combine the two treatments, first leaving the crop in the field and then afterwards storing at higher moisture content, then we get really alarming results. And this is actually not, this is an experiment that simulates what's actually happening in many countries. In Cambodia it's still happening, in Myanmar it's happening, in Laos it's happening. So our conclusion is basically, maybe you might be aware of that only around 8 to 9% of the rice is internationally traded. And that rice is usually the one that gets subjected to testing and so on, and that usually comes from the better post-harvest systems. And that leads to the conclusion that probably in the rural situations we do have a problem with mycotoxins. And we have now, within the project, we have set up experiment to quantify that in several villages in the Philippines. So what can we do to minimize those dangers, and minimize the losses, and also minimize the potential for mycotoxins to develop? So the first one, it's all not, I think, Dr. Schäfer-Preuß also mentioned, the technology that we are working with might not be too exciting in terms of science. It's not rocket science, but that's actually what's not needed. What is needed is basically improving the current post-harvest management along the value chain. And the first step is basically to eliminate the delays in the post-harvest operations. That's the most important one. Minimize the handling of grains after harvest.